evening. Welcome to the Mind of STEM channel, where you get your daily dose science, technology, engineering, and math. My name is Leon Jones, and this evening I'm going to talk about a term that is used in industrial engineering. And that term is SPC, Statistical Process Control. So the title of this video is, why do we use statistical process control? Why do we use statistical process control? Well, first of all, when we deal with SPC, statistical process control is defined as the use of statistical techniques to control a process or production method. SPC tools and procedures can help you monitor process behavior, discover issues in internal systems, and find solutions for production issues. Statistical process control is often used interchangeably with SQC, statistical quality control. Now, when we deal with SPC tools, a popular SPC tool is the control chart. Now, the control chart was originally developed by Walter Schubert in the early 1920s. Now, a control chart helps one record data, and it also lets you see when an unusual event is taking place, such as a very high or very low observation compared with typical process performance as it occurs. Now, control charts attempt to distinguish between two types of various processes. Number one is the common cause variation, which is intrinsic to the process and will always be present. Number two, special cause variation, which stems from external sources and indicates that the process is out of statistical control. Now, there is a comparison, SQC versus SPC. Now, statistical quality control is defined as the application of the 14 statistical and analytical tools, 7QC and 7 SUPP, to monitor process outputs, which are dependent variables. Now, SPC, which is statistical process control, is the application of the same 14 tools to control process inputs, which are independent variables. Now, although both terms are used interchangeably, SQC includes acceptance sampling, where SPC doesn't. Now, the 7 quality control or 7 QC tools, they were developed, brought together by Dr. Ishikawa back in '74. It's a collection of process improvement tools, and he has a text out called the Guide to Quality Control, known around the world as the 7 Quality Control 7 QC tools. They are cause and effect diagram, also called Ishikawa diagram or fishbone diagram. If you're familiar with industrial engineering, supply chain management, production process, these terms are in your backyard. It's the check sheet, the control chart, the histogram, the Pareto chart, the scatter diagram, and stratification. Now you have the 7 subtools, which sub is supplemental tools. And they are data stratification, data maps, event logs, process flow charts, process centers, randomization, sample size determination. Now, here's the chart. This is the relationship between SQC and SPC. The design of experience, the design of experiments and analysis of variance, or ANOVA. Now, of course, with everything, SPC has a history. Now, a marked increase in the use of control charts occurred during World War II in the United States to ensure the quality of munitions and other strategically important products are controlled properly. And it also gives us an opportunity to make sure that we have quality munitions. Munitions are ammunitions. Now, the use of SPC methods diminished somewhat after the war, though it was subsequently taken up with great effect in Japan, and it continues to this present day. Now, many SPC techniques have been adopted by organizations around the globe in recent years, especially as a component of quality improvement initiatives like Six Sigma. The widespread use of control charting procedures has been greatly assisted by statistical software packages and sophisticated data collection systems. Again, there are also additional tools. Now, additional tools are QSUM, which is cumulative sum charts. The ordinate of each plotted point represents an algebraic sum of the previous ordinate and the most recent deviations from the target. You also have the UMA, which is the exponentially weighted moving average, because under this monitoring tool, each chart represents the weighted average of current and all previous subgroup values, giving more weight to recent process history and decreasing weights of older data. Once again, when it comes to SPC, statistical process control is defined as the use of statistical techniques to control a process or production method. SPC tools and procedures can help you monitor process behavior, discover issues in internal systems, and of course, find solutions for production issues. That concludes this topic of statistical process control. Let me know what you think. Please like, share, and subscribe to the Mind of STEM channel. And on this channel, I'm giving you a daily dose of science, technology, engineering, and math. And if you're looking for more political and social topics, check out the 401 Talk Zone radio show, also on YouTube and Blog Talk Radio. Now, if you can't find me on YouTube or Blog Talk Radio, you can find me on Twitter, MeWe, and of course, Parler. And once again, I thank you for listening to this edition of the Mind of STEM channel. And on this channel, I'm giving you a daily dose of science, technology, engineering, and math. And you can also check out my first video I did on critical infrastructure, because scatter plots tie into that critical infrastructure video. But if you're interested in industrial engineering, operations management, which includes linear programming, industrial management, this is the video for you. So once again, I thank you for listening to this edition of the Mind of STEM channel, because on this channel, I give you a daily dose of science, technology, engineering, and math. Until next time, my name is Leon Jones. I want you to have a wonderful and gracious evening. And God bless you.